Bismillahirrahmanirrahim. Inshallah, today we'll start section 2.3, and I'm trying to do it in topic wise. So the main idea is to find the limits in an analytical way, I mean in an algebraic way. So I'll talk first about the properties of limits, and I will do examples. This is in this video. Then in a second video, I'll talk about strategy to find the limits. Then I will go to the other topics for this section. Try to put one topic in one video to make it easy to check. Okay, so properties of limits. These are the main theorems. What we have for the functions, for constant function, or like in this one, the limit just substitute. So since it's b, so the result will be b for any x goes to c. For the function x, also you just substitute, so it will be c. For the function x to the power n, you just substitute, so get c to the power n. Actually, we'll talk about it in section 2.4. For any continuous function, the limit you just substitute. Finding the limit is similar to doing substitution, and that will be for all continuous function. Now, also you have properties of limits. It says what? You have b and c are real numbers, n is positive integer. You have two functions, f and g. The limit of f of x as this goes to c is equal to L. Limit of g of x is goes to c is equal to k. So the limit exists for f of x, it's equal to L. A limit exists for g of x, and it's equal to k. What will happen to the sum? Just the sum of the limits. The difference of the limits. A constant times the function, take the constant outside, and just you have the constant times the limit of f of x as it goes to c. Product, same thing. Quotient, same thing. But you need to be careful, the denominator not equal to 0. Function to the power n, you can take the limit inside, so that will be L to the power n. So if I want to do this, actually I will substitute, but just to follow these rules, we can say this one, since the sum of two functions, where the limit of this function exists and the limit of this function exists. So I can distribute the limit. Limit x goes to 2, 4x squared. Plus limit x goes to 2 of 3. Now this is the constant times the function. I can take the constant outside. Plus limit x goes to 2 of 3. That will be what? This one, I can do this theorem. So 2x squared, it will be c squared. And what is c? Is 2. So it will be 4 times 2 squared. This one is just a constant. So I can do this. You get what? You get the 3. Add them. You have what? 16 plus 3, which is 19. That will be the answer. Now, actually, it's more than that. If you have any polynomial, since the polynomial functions will be a continuous function, to find the limit, just substitute. So this one, it's just a polynomial. So to find the limit of this one, 4x squared plus 3, what I will do, I just substitute. Since this is a polynomial, 2 squared plus 3, which is 19. Okay. Actually, if I have a rational function, and c is in the domain of that rational function, so g of c not equal to 0, I need this condition. What I will do, you just substitute. The limit is like substitute. So if you look at this one, 1 is in the domain of this function. Consider this f of x. So 1 is the domain of f. Since the denominator not equal to 0. If you have 1, the denominator will be 2. So what I will do, you just substitute. You have 1 square plus 1 plus 2 over 1 plus 1. That will be what? 4 over 2, and that will be 2. Okay. If you have a function involving a radical expression, what you will do? F n odd, you know that if you have a radical where the n is odd, then the domain is odd real number. So you have nothing to worry about it. You just substitute. If n is even, you need c to be positive to substitute. I need this c to be positive. Okay. The composite function. What does it mean? The composite function, you have function of function. If you have function of function, how to find the limit? I need to be sure about what? The inside limit. Actually, how I can take the limit inside, huh? You have function of function. You have f circle g of x, which is f of g of x. So how we can take the limit inside, like what we did, under these conditions. This limit exists, it's equal to a value L, and the limit of f of x, so this will be the outer function, the limit of the outer function as x goes to L, which is the limit, this limit g of x, as it goes to L is equal to f of L. Actually, this is, we'll call it the continuity later. This is the continuity, meaning f is continuous. So if you look at this, you have the outer function or the inner function is the x squared plus 4. And the outer function is the square root. Since this one is the square root of this expression. So this is the inner one, and the square root will be the outer one. Okay, so I need to apply the conditions. I need the limit of g of x as x goes to c, as c is 0. Huh? That will be what? This is just a polynomial, so I can find the limit quickly. X squared plus 4, that will be 4. So this condition satisfied. I have a value L. Now we need to check this condition. Limit. Now what is L? This is L. Limit x goes to 4, that will be my L, of f of x. That should be equal f of L. Huh? So what is this? What is my f of x? F of x is just the square root. Limit x goes to 4 of square root of x. Since this is positive and this is the root is the n is even, so I can substitute. That will be square root of 4, which is 2. So we can apply this theorem, since n is even and c is positive, 4, which is equal f of 4. Huh? F of 4 is what? Square root of 4, which is the same thing, 2. So this condition also is fine. So the limit of x goes to 0 of this one. I can take the limit inside the square root. That would be square root limit x goes to 0 of this. Now I can do the calculation. That will be, this limit is 4. That will be square root of 4, which is 2. That will be the answer. Okay. So actually, I just substitute directly from here. Huh? More than that, if you have any of these functions, sine, cosine, tan, cotan, if c is a number in the domain of the function, then finding the limit is just substituting. Just substitution, nothing to worry about. Okay, so like this one, 0 in the domain of f. This is my f. So how to find the limit? Just substitute tan 0, which is 0. 0 is the domain of this. How to find the limit? Just substitute. You get 0. Minus 1 in the domain of this one. So just substitute. It will be minus 1. E is minus 1. Minus 1 over e. E in the domain of this function. So we just substitute ln e cubed, which is 3. This one. Actually, we did it before. We talked about it before. This is a polynomial. How to find the limit? Let me do this one here. 1. Just we substitute. So say, since it's a polynomial, you can do the calculation quickly. Just substitute. Be careful. 3 times minus 2 to the power 4, 3 times 16, that is 48. Here 4 plus 8, 4 times 2, minus 2, that is plus 2, plus 1. That will be what? 11 plus 49, which is 59. Okay. Second problem. This is just a polynomial. Huh? Polynomial, yeah, just when you do the product, you will get a polynomial at the end. So how to find the limit? Just substitute. Nothing to worry about. You have what? You have 1. This is t squared plus 1 cubed. 3 minus 1 to the power 5. That will be what? 2 cubed times 2 to the power 5, which is 2 to the power 8. What is 2 to the power 8? Yeah, 256. Yeah, you can check it. Yeah, 2 to the power 5, 32, 64, 128, 256. Yes, 3. This is a rational function. If you remember, when you talk about the rational function, what did we say? If the denominator not equal to 0, then we can do substitution. Check. Check here. This is g of x. This is f of x over g of x. Check g at 2. G at 2 equal what? 4 plus 12 minus 4. Not equal to 0. It's equal to 12. So it's not equal to 0. So how to find the limit of this? We just substitute. You get what? 2 times 4, 8 plus 1 over, we just calculated, that was 12. That's 9 over 12, which is 3 over 4. Okay. Now we'll also do something with the piecewise function. Actually, we did it before in 2.2, but this is the idea. If you look at this function, yeah, what you need to check it from left and right. But this function, it says what? It's x plus 1 if x not equal to 1. When he said x not equal to 1, that means what? He include x less than 1 and x greater than 1. He include both of them. When he say x not equal to 1, because the rest is x equal 1. So that will be x plus 1 if x less than 1, pi if x equal 1, x plus 1 if x greater than 1. So how to find the limit? We find the limit from right and from left. From right more than 1, so it will be here. So I'll take this function. How to get this is a polynomial? So what I will do, substitute 2. What about the limit? This goes to 1 from left. I will be there. So I'll take x plus 1, which is also give me 2. So both they are the same and they are equal to each other. So that means the limit of g of x, as this goes to 1, is equal to 2, like what we did in 2.2. The same thing here, that will be easier. Limit, as this goes to 4 from right. So I am here. It will be square root x minus 4. Let me do it in steps. F of x. So I just substitute. From right, everything is defined. You have no problem in the calculation. That will be 0. What is the limit? It goes to 4 from left of this function. From left, I'll take this. That will be limit. X goes to 4 from left of 8 minus 2x. Just a linear function. Just substitute. 8 minus 8, that will be 0 also. Both are the same. So that means what? Limit x goes to 4 of f of x equals 0. Yeah. Another problem, quickly. 2 from left. 2 from left, so I am here. So I take this limit of 4 minus x squared. That will be 4 minus 4, 0. Right will be here. So I have x minus 1. That will be 1. So what will be the limit? As x goes to 2, does not exist. Because right, not equal to left. Yeah. Now, sometimes you'll give you a graph. I have the graph, I have this graph, and they want to find the limit. Yes, we just check it. Huh? Now we'll do a limit. X goes to minus 2 of f of x. Where is it? Oh, this is minus 1. This is minus 2. So, because f of x is the red function, and g of x is the blue one. So minus 2, I have what? Limit f of x is goes to minus 2. For sure, it's 1. What is the limit? As this goes to minus 2 of g of x. G of x for minus 2, it will be minus 1. So both limit exists, so I can distribute the limit. So I have limit as goes to minus 2 f of x. This is 5, you can take it outside. So what are we getting? We're getting 1 plus 5 times minus 1. Correct? Yeah, 5 times the g. The g at minus 2 is minus 1. Yes, and that is 1. Correct. That will be minus 4. Okay. Now let me check this one. Huh? Let me use this space. So I want the limit as this goes to 1 of f of x. Be careful there. X goes to 1 for f of x. That will be 2. That will be 2. What is the limit? As this goes to 1 for g of x. X goes to 1 for g of x. The limit does not exist. Why? Because the limit is goes to 1 from right is equal to 1 from right more than 1, so it will be here, that will be minus 1, and the limit is goes to 1 from left less than 1, so it will be here, that will be minus 2. Okay, now what will happen to the limit of the product? I cannot apply this theorem, because this theorem is saying if both limits exist, then we can say the limit will be, we can distribute the limit, or the limit of the sum is the sum of the limit of the difference and the difference of the limit. But now one of them exists, the other one does not exist. So we need to check it. We need to check this from right and left. Since what? Since when he said, I know that the limit x goes to 1 if of x is equal to 2, that means, the limit as goes to 1 from right should equal the limit as it goes to 1 from left equal to 2. Since the limit exists, it means from right and left should be the same. So I know the limit x goes to 1 from right for f of x, and the limit goes to 1 from right for g of x, and the same thing from left for f and g. Okay. Then I can use this information to try to find the limit of this one. So I'll do it from right and left. So limit x goes to 1 from right. Yeah, notice this limit exists from right. So I can distribute the limit from right only. Huh? So that will be what? From right, I have f is 2 and g of minus 2. So it will be 2 times minus 1, which is minus 2. Now, what will be the limit? As this goes to 1 from left. Notice the same thing. This exists, as this goes to 1 from left. So I can apply the theorem. So for s goes to 1 from left, for f is 2, for g is minus 2, which is minus 4. Now what that means, what? The limit, as this goes to 1, of f of x times g of x does not exist. Why? Because right not equal left. Now let me do this one. Limit as goes to 2 for f of x. what will happen? X goes to 2. This is 1, this is 2. So it will be here somewhere between 1 and 2. So let me say approximately 1.4. Who cares? Huh? Limit this goes to 2 of g of x. Now this goes to 2 for g of x. G of x 2, I will be here, so that will be 0. So I have non-zero over 0. For sure, this limit, we say, does not exist. This limit does not exist. Okay? Yes. Now, yeah. Now let me do, yeah, this is what we have. So what we have in these properties, we have for these basic functions, if C in the domain of the function, then we can just substitute. We can just substitute. And we have, if both limit exists, then you can distribute the limit for the sum and the difference and the product and the quotient. Let me do some old questions, old exams questions. Okay, then we'll do these old exams questions. Okay, he says if the limit x goes to 2 exists, and he puts a c somewhere here. He wants to find the c. When he says c cubed plus c, I need to find the c and just plug it here. Maybe I need to find the c. Okay, if he said the limit exists, this statement means what? The limit, as this goes to 2 from right, equal the limit, as this goes to 2 from left. Okay, from right means I am greater than 2, I will be here. So that will be limit, as goes to 2 from right. What's the function? Square root x plus c. And here the limit is goes to 2 from left for this function. Now I can substitute because it's yeah, everything is defined. We have nothing to worry about. So that will be square root 2 plus c equal, you have what, 3 minus half times 2, 3 minus 1, that is 2. So that means, now just an equation for c. So I need to find c. Square it, 2 plus c equal 4, so c equal 2. That means this expression, c cubed plus 3c minus 7 equal to what? 2 cubed, 8, plus 6 minus 7, and that will be 7. 14 minus 7 is 7, so this will be my answer. Same idea. This limit exists, means the limit from right equals the limit from left. So from right, I will be there. So that will be the limit for this function. And that will be the limit less, so I'm less than 1. So for this function, just I need to find c. Plug the numbers, what you have? 1 minus 2 squared, that will be 1. Here you have what? Square root 1 plus 1, 2 plus c. So 2 plus c equal 1. Just square it, so c equal minus 1. So 2c plus 4 will be minus 2 plus 4. That will be 2, and that will be the answer. Yeah. 16 minus x to the power 1 over 3 over 16 minus the square root of x. Okay, you have function over function here. This is limit f of x over g of x. But notice, g of 64, g of c, is equal to what? 16 minus square root of 64, which is 16 minus 8. That will be 8, not equal to 0. So I can just substitute. No need to think about rationalizing all of these things. Huh? X goes to 64. You can just substitute. No need to do all of this. Just substitute. You have 16 minus 64 to the power 1 over 3 over 16 minus square root of 64. Actually, we did this. This is 8. So that will be 16. A cube root of 64 is 4. 16 minus 4 over 16 minus 8. That will be 12 over 8. Divide by 4, 3 over 2. That will be the answer. The graph of f and g are given below. Then he wants to find this limit. X goes to 1 from left. be careful here. I have x cube, I can do, no problem, because you just substitute, it's a polynomial, f of 2x. So I need to find limit x goes to 1 from left of f of 2x. Be careful here. If x goes to 1 from left, that means 2x will go to 2 from left. I'm choosing a value less than 1. 0.9999 times 2, still it will be less than 2. Some value 1.99 something. So it will be 2 from left. So now I check the limit as it goes to 2 from left for f. Okay, because 2x goes to 2 from left, I need to find f of this. 2 from left. 1, this is 2 from left, so it will be here. So that give me 2. So that will be 2. Now check limit as it goes to 1 from left of g of x. Yeah, 1 from left. 1, this is 1 from left, less than 1, that will be 2 also. Okay, so what is the limit? As it goes to 1 from left of x to the power 4, f of 2x, all limit exist. Since I'm doing it only from left, so I just substitute. You have minus 1 to the power 4. This one, I know it, it's 2 plus 3. This one is 2 again. So that will be 2 plus 6, which is 8. And that will be the answer. Okay, look at this function. This is g of x, by the way. Yeah, because he said using the graph of g of x. And this is f. Okay, you want to find x goes to 0. So to check x goes to 0, I need to check left and right. Okay, for f of x. Now I need to find limit x goes to 0 of f of x. Yeah, I don't know what is it. So we'll do from right. From right means I'm there. So I just substitute 5 minus x, we get 5. From left, it will be limit x goes to 0 from left. Left I am here, so it will be 1 over x squared minus 1. Just substitute, because it's not 0 is not in the domain of 0 in the domain of these functions, we have no problem. So it will be minus 1. Left not equal to right. So this limit does not exist. Okay. Now let me go to g of x. I need to do the same. Let it goes to 0 for g of x. I don't know what will happen. Let me check left and right. Let me check the right for 0. 0 from the right, it will be there, so that will be minus 2. From the right mean more than 0, more than 0, so it will be somewhere here. Okay. Limit x goes to 0 from left for g of x. So it will be somewhere here. So that will be 2. So left not equal to right. So that does not exist. Can I apply this theorem? No, we cannot apply this theorem, because this theorem is saying what? If the limit exists for both of them, then I can distribute the limit. Okay, I cannot do it for the main function, because this is, as x goes to 0, because both limit does not exist. However, I can use it for the right, since both limit exists for the right, and I can use it for the as it goes to 0 from left, since both exist. Okay, and this is what I will do for this function. So instead of doing limit x goes to 0, I'll do limit x goes to 0 from right. Now, can I distribute the limit? Yes. Why I can do this? Because this limit as it goes to 0 from right exists. Limit of g of x as it goes to 0 from right also exists. So I can distribute the limit. F of x minus limit g of x as it goes to 0 from right. That give me what? 0 from right for f of x is 5. 0 from right for g of x is minus 2. Wait a minute. Yeah, this is minus 5, sorry. It's x minus 5. Why am I making it 5 minus? This is x minus 5, sorry for that. That is 0, that is minus 5. Yeah, so this is minus 5. Yeah, x minus 5 from x goes to 0, yeah, it will be minus 5. Sorry for this mistake. Okay, so this is minus 5 plus 2, minus 3. Now let me do the limit as this goes to 0 from left. Can I distribute the limit? Yes, because it goes to 0 from left exists. It goes to 0 from, for g of x also exists. So I'll do this. That what is f is minus 1, and this is g minus 2, that will be minus 3. Both are the same. Look, limit of x as it goes to 0 does not exist. Limit g of x as it goes to 0 does not exist. But their difference, the limit is the same from left and from right. So that means the limit is to 0 of f minus g at x will equal minus 3. And that will be my answer. Yeah. Yeah. As I said, I want to do like short videos. So in this video, just we talk about the properties and we'll try to do problems just to talking about these properties of limit. So let me stop recording. Yeah. Thank you.